Hey there, Mr. Wilford here. I wanted to continue our discussion here with Chapter 6, Section 3, Dividing Polynomials. In the first part, I talked about dividing polynomials using long division, and I did this problem here. In the second part now, what I'd like to do is talk about something called synthetic division, and this is kind of a shortcut for dividing polynomials by a linear binomial. So we want to have something that kind of looks like this, some x minus a. And the nice thing about this is we can just do this using the coefficients, and we can kind of get rid of the variables and kind of clean it up a little bit to get our answer. For synthetic division to work again, I kind of talked about this before last time. The polynomial must be written in standard form, and we have to put 0 in place for any of the missing terms. So I'm gonna take a look at some problems that I have here, actually one of them, and there it is right there. I'm actually doing this one right here on the bottom, and I'm going to divide these polynomials using synthetic division. What's going on here is the first thing you want to do is actually take a look at this binomial, this part here, and x plus 3, take that denominator and set it equal to 0, which is what I did over here. Set it equal to 0, solve for x. So basically you subtract 3 to both sides, x equals 3. This is what we call our corner number, and that's the number that you start with. And then what you're going to do is you're going to write the coefficients down in order. Again, making sure that this is in standard form, and the coefficients that I'm talking about, there would be a 1x to the 4. You can see that I don't have an x cubed, so that's where the 0 comes in. I don't have an x squared, so I have another 0. And then I have an x there, so the negative 5. And then I have a constant, which is 10. So those numbers you can see right down here I have listed. Now, the synthetic division part, after you do this a couple times, you'll find that it's actually pretty easy. There's kind of a pattern to this, and I'll try to go slow. So what you do is you always want to bring that first number down first. You don't change that very first number. So what I did is I wrote the coefficients down, I skipped a line, and then I drew a line. And I'm going to bring that first number down and rewrite that as 1. Then the numbers that you have below this line, we're actually going to multiply to the corner number each time. So right now I'm going to take 1 times the corner number negative 3, and that number goes here. Then I'm going to add those two numbers together, so 0 minus 3 is negative 3. And again, negative 3 times the corner number, negative 3 times negative 3 is a positive 9. I'm going to add, so 0 plus 9 is 9. 9 times negative 3 will give me negative 27. So again, I'm taking the number that's below the line and I'm multiplying it to that corner number, and that goes here. And then I'm going to add here, and this is negative 32. And then I'm going to take that number times the negative 3. Alright, then I'm going to take negative 32 again times negative 3, and I get positive 96, and then I add those two together and I get 106. Now, where do we get our answer from? Well, every time we divide a polynomial, you have to talk about the degree, or look at the degree. So we started with an x to the power of 4. Let me change colors here. This was our power, so this started with a degree 4. Every time you divide polynomials, you actually knock it down 1 degree. And these numbers here are actually going to be the coefficients to my answer. So I start with a 1, and now I'm going to go down a degree from 4, so it would be x cubed minus 3x squared plus 9x minus 32, and then I have a remainder here of 106. Again, sometimes you'll see it as 106 divided by x plus 3. And there's my answer. If you have any questions with synthetic division, please let me know. Thanks.